Let's take a look at number 8 here in the picture of this textbook. I love this problem. This is a cool problem. We've got a rectangle inscribed in a semicircle. And essentially what we're asked is to come up with first an expression for the area of the rectangle as just a function of x. So just x is in that expression. And then later we're going to do the perimeter as a function of x. So let me start by talking about the area. I'm going to just draw a little picture on the side here of a rectangle, and I want to just talk about how you find the area of a rectangle. Back to your geometry class, you'll probably remember that we do the area by multiplying the length and the width, right? Area equals length times width. Now what we're asked to do in this problem is write that formula so that all we have over here is functions of x. So expressions with only x in them. So we can't use L and W. But what I want to do then is just kind of draw this L. Woo, baby, I just moved the whole picture, didn't I? I wonder how I did that. Let me move these individually. I'll put this back here. That was a little glitch. So the L on my rectangle, this guy right here, is this distance here. And believe it or not, that's easy to express in terms of x. Because whenever you're measuring the distance from the y-axis to your point, that distance is literally just x. So if this little distance here from the y-axis out to the point P is x, I'm essentially saying on my picture this side is x. Well, that's just halfway over. That means this guy is also x, right? And if you look here, that means our L is just 2x. So we've taken care of the length. The length of our rectangle is really 2x, just based on what I drew on the picture over here. Now, it's also pretty easy to figure out how tall this rectangle is. That's just the distance from the x-axis up to our point. That's just y. So essentially what I'm saying is this w here is really just y. So my w is just y. I'm one step closer to figuring out what this formula is, but I still have a y in my expression, right? If I write it out right now, I have a equals length, which is 2x, times y instead of w. Still 2 letters, but I'm close. And then I look at the picture and I'm like, doggone it, they told me what y was. It's just the square root of 4 minus x squared. So we wrap this letter a up by writing out a, the area, capital A, is 2x, which is my length, times y, which is the square root of 4 minus x squared. And this thing is a function of x. Only x is the only variable, right, in this expression here. So for letter A, area is 2x square root of 4 minus x squared. Well, we're going to do the same process for letter B, except we want to know the perimeter. So if I look at the perimeter, it's just adding up the distance all the way around this rectangle. So if we were just working with L and W, let's start with a new rectangle here. Let's see if I can erase this bad boy. I can't. Look at that. It's not all erasing. I need to figure out how to make this thing erase. Well, I'm only doing one take on this video, but essentially let's just sketch the... So I've got L and W, and this guy's L and this guy's W. If I add it up that way, it's just 2L plus 2W, right, to get the perimeter. If you started on one corner and walked all the way around, you'd go L, W, L, W, 2L plus 2W. We can't have L and W in our expression, though. We can only have X's. But remember, we know what L and W are from this part here. So for 2L, that's going to be 2 times 2x, so that's 4x. So there's x here, x here, x here, and x here. That's 4 x's. And then for the 2w, that's really 2 y's. And we know y is the square root of 4 minus x squared. So I'm just going to say this is 2 square root of 4 minus x squared. And that's what they're asking us in letter B here. When they ask you for a function of x, you need x stuff in your expression, numbers and x's. And the area is length times width, and the perimeter is 2L plus 2W. Again, we ended up with just x stuff in this one. Okay, that was a lot of rambling, you know, but it's kind of late at night. So hopefully this gives you an idea of how to attack number 8 and problems like it. We actually will use this picture later in calculus, and we're going to maximize the area of that rectangle, but that's something for the future. Good luck with everything. Take care.